So that is very classical, this thing, and kind of known that I didn't give you really references for that. Okay, but I think it is very easy to find. Money, interest, and price. You can find it online. There is a nice paper by Stan Fisher, which you can find as so. If you don't want to read the whole book, which is fairly repetitive, but it's long. There is a nice piece by Stan Fisher as an MBR working paper. It might have been published somewhere, I remember it was an MBR working paper, going through the book and its limit and what it was trying to do, written some years ago, and I don't remember if it was the 25th anniversary or the 50th anniversary of the publication of Money, Interest and Prices. Doesn't matter. You write Stanley Fisher, Money, Interest and Prices, MBR, and you find it. That's a much shorter review to read. If you're curious, you can read the whole book, but given that it was a technical book for the times, but it's no longer the frontier, it's only, and while it is a nice book with a lot of insights here and there, I don't think it withstood well the burden of time. Why? Because this is what it wants to show. So, yeah, in order to get people to hold money here, we need to get some money demanded, and then, money supplied, and then whatever the money J demands to hold at the end of T, or at the beginning of T plus 1 if we introduce time, which I will do in a moment using this, okay? And then you get, now notice, so yeah, in this model, under certain assumption on the here, you get the separation. And Patinkin's purpose actually was very clear. He wanted to get to he wanted to provide what at the time was the most precise formulation of the very basic idea. The money solves the barter problem, that if you add money, okay, to the Varesian model, and the only purpose of money is to facilitate transaction as in the quantity theory, money acts as a veil, and therefore relative prices and quantity gets determined in the real value, in the barter. It's a particular barter because it's a centralized barter, okay? It goes through the Varesian auctioneer, but prices, relative prices of goods and the quantities traded gets determined in the barter side, and money justifies the absolute prices. In fact, he has parts in which he discusses what happens in that world when you let money shrink. Right? And he doesn't even seem to notice that even that is a meaningless exercise, because when I write that equation and I endow people with a pile of money, I can make money shrink or amplify by purely defining the unit of measure. Is that dollars? Hundreds of dollars? Cents? 1/100th part of a cent? You say money in this form is really a pure veil. There's not even a meaningful sense in which you make the quantity of money vary here, because it boils down to a unit of measure. You understand that? So particularly go through these figures, says take the model and compute its monetary equilibrium, let the quantity of money available shrink. First of all, you have to shrink it uniformly. So it's not really trying to describe any system in which you're withdrawing money from the system, because to withdraw money from the system, you have to withdraw from some guys and not the other. Okay? So it's really defining a reverse helicopter in which money gets siphoned up from each household uniformly at a constant rate. But that's completely equivalent as saying we don't measure money in centimeters anymore, we measure it in kilometers. which also suggests that per se in the system as it is defined, that's no problem, because all you have to do is to change the unit which you measure velocity. And it also makes you understood that velocity is a perfectly arbitrary measure, because it depends on the unit on which you measure money. I can speed up money enormously by measuring the units of money no longer in dollars, but in thousands of dollars. And vice versa, I can slow down money by measuring things in cents, right? Now, I'm not trying to ridicule this, right? It's a relatively useful thing, and as a first approximation, many historical experience pre-1820, 1850 proves that even if when money is treasured and pulled away from the economy for a reason or another, and money is circulating in the form of, coins and precious metals, this effect more or less shows up, even if not perfectly as in the equation. And when you put it back in, because there is an outflow of money coming from some source, even if it doesn't get distributed the exact X% per household, you do get more or less uniform inflation. And in fact, if it is not uniform and it varies from good to good and region to region, it's exactly because the extra money coming in goes, faster or in larger quantity in a region or in another. So one doesn't want to ridicule the model, okay? If one wants to use it to understand what it's worth understanding, it does fine. It's not such a stupid thing, okay? But if it is a way of understanding other things, then certainly should not be taken true. And in particular, that's where I think Patinkin really had a problem, and I remember the discussion at UCLA in 87, 89 with Joe Ostroy, is that in order to understand the role of money in a competitive model where money solves a transaction purposes, it's not a good model. Why? Because if what it has to solve is a transaction cost purpose, you better put transaction cost. Right? So a few years after Patinkin came up with this, which in my view is just the pure idealized variation model with a useless object called money, that useless, doesn't solve any transaction purpose. Useless object called money that people magically hold because they're told to hold it, and that's it. All right? We're not explaining why they hold it. Yeah, fine, you put in utility function. We'll get the utility function thing in a moment. Then it has the veil and the duality purpose and blah, blah, blah. And it's neutral, okay? A few years later, Joe Ostroy and Ross Starr worked out general equilibrium models of transaction costs. That is, models of this type, without the money part, in which trading requires resources. I'm not going to go through this, there's no time, okay? I think it is an area of investigation that has not been particularly successful. I think it was widely quoted at the time, and then people didn't continue it, and I think it's worth taking a look. I don't know if there is a question we can ask those models, or if we can write down those models in a better form these days to study the way in which the evolution of financial tools and monies have changed our way of trading. But I think that as a tentative of trying to clarify that what money does, one of the things that money does is to reduce transaction cost, that was a good tentative and certainly was the first. So Joseph Ostroy, Ross Starr, you will find a bunch of papers on that. Joe stopped working on that, went on working on other things. Starr kind of stuck around that. He published a book of his notes a few years ago. I think it's Cambridge University Press for those that are interested. I have to say, admittedly, that the book is quite confusing. I don't think Ross edited his notes very much. And so, he's older than me. So the notes, I mean, they're okay, but it's the kind of stuff that is written in a bit of a complicated language. If you want to take a look at it. But at least you have an idea what that literature was. Once you put transaction costs, then depending on how transaction costs are and how money reduces them, it's obvious the money need not be neutral. In the strict sense, it cannot be neutral because if transaction costs are real and consume real resources, either they uniformly consume all resources at the same rate, or if they consume only some resources, for example time, labor time, and not other, then once I put money substitute for labor time, and so it de facto increases the effective supply of labor time. It doesn't increase the effective supply of ice creams or movie theater or whatever, right? And therefore it's bound to change relative prices. That's a trivial observation, right? So either transaction costs are just a general iceberg kind of or uniform tax on the endowment of every resource you have, right? So that when in the world without money, you basically have an endowment vector multiplied 1 minus something. And that something is the same for every individual. But then that's a pretty silly way of thinking of money, right? And what money does proportionally is as you increase the quantity of money, it reduces the something you take away, again uniformly, or there are no chances that it's neutral. It's pretty obvious. Just write down a basic model where you have 2 3 goods, labor, capital, and land. If money, if the transaction cost is just labor time, money saves on labor time, increases leisure, increases the labor supply, doesn't do anything to capital and land. That's going to change relative price, going to change capital labor intensity in the production function, right? That's obvious, okay? So that's a more promising way to go. It still makes the whole argument about raise velocity a bit ambiguous, because again, there is a problem of unit of measure, and there is also the fact that if you don't model explicitly the transaction and exchange system, it's not very clear what it means to replace time for search with money. From this point of view, a well-specified search model with transaction cost would probably be more useful, because you can see where money is going, what is that it replaces, okay? But I also want us to say that those type of literatures are not very different. The transaction cost view and the search view, frankly, in spite of the fact the search is today very popular, is not very different. The insights you get on the role of money is not very different. And again, it is insights, they are insights on that money, that in your pocket. It has nothing to do with reserves at central banks. And any time that you say, oh yes, but the money circulating has a relation with reserves, no. Right? In fact, the amount of cash circulating in the economy hasn't changed much since, say, 2008. The amount of reserves have changed a lot. And the answer say, oh, the bank multiplier or this or the other multiplier have changed, and that's tautology, okay? Yeah, by definition it does change, that means you have to tell me the mechanism. Okay, so that's the stage. And then you remember, you see, this is all influenced by the fact that we use, or we want to use, the Eurasian model as a starting point. And because people were not happy with that, the search goes on. So for a long time you get, all the 60s is Patinkin world. At the end of the 60s you start getting the transaction cost thing going around. It's still complicated, for whatever reason, doesn't take off. Few people write papers about, they're interesting, but it doesn't really get used, right? In fact, if you look at the status of these models in the early 70s or middle 70s, what is that you find? You find what I mentioned the other day, Brock paper, Journal of Monetary Economics, right? What is the Buzz does? Buzz says, well, let me integrate monetary theory and growth theory or standard optimization theory. And he writes a simple model. I'm going to go rather quick on this, okay? Writes a model like this: representative agents continuum of representative agents, maximize something like this, right? We have a simple world where agents have an endowment in each period and have an initial set of cash balances and a final set of cash balances, right? Given that cash balances offer utility, this makes sense. And then there is consumption. Where are prices? Whereas cash balances are real cash balance. So in this approach, this is what cash balances are. Now one has to be careful here, and I don't want to go through that. I remember pointing this out. It's a technical issue, but it's somewhat amusing. If you go and if you're curious about this, you don't have to do this, but if you're curious about this, you can go read the original Brock model, and you will see there is an incongruence in the way Baz writes the resource constraint. Why? You see, what's the argument? The argument is cash balances enter your utility function because they reduce your time wasted in trying to go around barter, and you can use cash. So way of thinking is you can derive this from a model in which you have consumption and time. Time, you use it for leisure. So you get utility from consumption and leisure. You don't work because it's an endowment economy, so you just receive the output from the sky, okay? So the time has only two uses, either leisure, that gives you utility, okay, or transaction. In the absence of cash balances, okay, you have to spend time, okay? And instead, if you have cash balances, you save time and you get leisure. The assumption is that this happens linearly. So the amount of leisure at your available to you, that's a trick, right? Goes up linearly. The amount of leisure available to you is proportional to your cash balances. Okay? Now, obviously, this cannot be in terms of nominal cash balances. Now, Brock, which actually uses, you remember I mentioned to you the last class, Sidrowski? Miguel Sidrowski, the guy that died, that wrote a paper in continuous time with super neutrality. Right. So actually what Baz does, he takes Sidrowski model and put it a bit in order and work it out in discrete time. Okay? And so correctly, people say, it's not nominal balances that make a difference, it's real. It's how much money I have given relative prices. So I can buy 3 apples, 7 bananas, 2 shoes, okay? So this is real, that's why I write it like that. But then one has to be careful, because this, which is expressed all in real terms, should be derived by a true budget constraint expressed in nominal terms. In nominal terms, the budget constraint is PTCT plus MT plus 1 less or equal than PTYT plus MT, right? Then I divide across by PT, okay? And I get that if and only if I multiply by the inflation rate, right? And then I also have to define how the quantity of money in the aggregate evolves. I have to write down an equilibrium equation for money. Again, this is a model of helicopter money. In fact, this is the simplest and cleanest model of helicopter money. All right? Because here now you can write an equation which says money supply right? This is money demand. This is endowment, sorry, this is what you have for previous period. And so there is a first order condition for money that will depend on inflation, right? And then you have to write an equilibrium condition for that. You have to say the nominal quantity of money you hold is equal to the amount of money the helicopter drops. Right? So this is an economy in which the helicopter drops money at time 0. People pick it up, drops it uniformly over the territory, so everybody picks up the bills that fall in their garden. Right? And then every morning, the helicopter goes around again and drops money again proportional to the initial dropping. So that's the way these models work. Right? You can make them with a heterogeneous agent. It doesn't matter. You make the heterogeneous agent disappear because everybody holds the same quantity of money and everybody's treated uniformly. Okay? Okay? So that's helicopter money. One note, if you check, Buzz actually makes a mistake.